My name is Laura Schickling. Welcome to the Takayama Lab. This summer, through the SURE program, I've been working with my mentor, Josh White, on ventilator-induced lung injury. More specifically, we want to know, when we take mechanical and fluidic stresses into account, which settings of a ventilator cause the most damage to cells. We're using a PDMS device that was developed for a previous paper published from the Takayama Lab. This device is able to apply mechanical and fluidic stress simultaneously. This device models an alveolar chamber and has been adapted to have 4 channels so we can perform multiple tests at once. After we trim the edges, we use the top half as a template to cut out the bottom half. Then, remove both halves from the dish. We then cut out 6 mm holes in connecting channels. The bottom half is where the volume actuation occurs, which stretches the membrane, while the top half is where we load the cells and the fluidic force is applied. After we punch all of the holes and cut the bottom channels, we have to plasma oxidize the 4 layers together. Plasma oxidation allows us to adhere PDMS together. The longer it's oxidized for, the more hydrophilic it becomes. After the first round, we have the bottom half attached to a glass slide and the top half with a thin PDMS membrane covering the channels. We then plasma oxidize the top half and the bottom half together. We insert syringe tips so we can control the volume fluctuation in the bottom half of the device, and then we surround the device with PDMS to prevent air leaks. We make the entire device hydrophilic, then insert the cells at a predetermined density and let them sit for 2 days until they form a nice monolayer on the membrane. Here you can see the membrane stretching. The stretch provides the mechanical force. When we add fluid to the device, the stretching of the membrane allows a meniscus to wash over the cells, applying the fluidic force. With the PDMS model of alveoli, we are able to model a variety of in vivo conditions. We would like to use this device to further assess damage done to epithelial lung cells under conditions that involve mechanical and fluidic stress.